All right, now we're going to start the tetrapod group. You'll remember from our fish lineage we were just looking at that Eusthenopteron, a type of fish very similar to the coelacanth in its anatomy, was thought to be also very similar to one of our most primitive forms of tetrapods, the Ichthyostega. Ichthyostega had 4 limbs for terrestrial movement, a fairly well developed 4-limbed animal. But also had teeth like Eusthenopteron. Remember we mentioned the labyrinthodont tooth. Meaning it has kind of folds all the way around it. So that's something that links these two, a fairly unique characteristic. There's a lot of other skeletal features that are common to Ichthyostega and Eusthenopteron. Ichthyostega also has fin rays in its tail. No living amphibian has, although they may have a fin-like structure, there are no fin rays in that, but Ichthyostega had fin rays in its tail fin. So anyway, we have some linkage going on here, some features that seem to tie these two groups together, similarities. Labyrinthodont fish and labyrinthodont amphibian. Yeah. So anyway, there are many different dead-end lineages that are supposed to be amphibian types of lineages that didn't make it through to living today. So the fossil record has a lot of variety of amphibian-like creatures that are not like today's salamanders, frogs, and caecilians. So anyway, a lot of extinct groups along the way here. This overall group right here we refer to as the Lissamphibia, L-I-S-S-A-M, phibia. Lissamphibia. The Lissamphibians include the salamanders, the order Caudata. Remember we go through kingdom, phylum, and class. We're in the class Amphibia now. Order Caudata, or also sometimes referred to as Urodela. Those are synonymous terms. But anyway, those represent the salamanders. Most of them have 4 legs, lizard-like structure, and a long tail. So that's kind of a consistent feature for most salamanders. There are some salamanders that lack the hind limbs and only have 4 limbs, and some salamanders have very, very minute limbs. But anyway, those are salamanders. The Anura, the frogs, Anuran group, frogs and toads are included in that, so all those that have that kind of hopping leg structure are grouped in there, easy to identify. The Apoda means without legs or without feet. The caecilians are only example there. We don't have any in this region of the world, but in the tropical regions, in various parts of the world, you'll find caecilians. They look like fancy earthworms in their overall body. They're elongate, moist skin with grooves around them that make a segmented look along their entire length. They do have jaws, though, so you can tell it's not a worm by that characteristic. A lot of other features of their anatomy would also indicate that they are vertebrate organisms, and they are amphibians in the group Apoda, the caecilians. So you may not be familiar with those, but they're just elongate amphibians without legs. So that's the Lissamphibia. These are not very well tied back to most of those that are in the fossil record, those odd groups that stem from the base of the amphibia. But anyway, these are the modern amphibians, the Lissamphibians here. Beyond that, we get to our first examples of organisms that have that amniotic egg. So here we have the beginning of the amniotes, and we see those epidermal scales show up as well as we head up this direction. A lot of the ancestral forms in this lineage are also gone. One of the most primitive types to stem through all of this, let's see if I can do this right, So this first branch here represents the anapsids. That means they do not have a fenestra on the side of the skull behind their eye. A fenestra would just be a hole or opening or depression in there. So anapsid group, one example of an anapsid reptile from that early lineage, there would be the cotylosaurs. Cotylosaurs. This means stem lizard or stem reptile, the earliest kinds of reptiles. And then there are side groups that go off from that. Beyond that point, above here we have this group that is considered the diapsid group. Diapsids. Diapsids have two openings behind their orbit, or fenestrae in the side of the skull, behind the orbit, one above and one below. Diapsid condition. And the other side over here, these are considered synapsids. We'll talk about those later, but those are on the way to mammalia, over that direction. Let's take some time now and look at the diapsid branch. The colonia, also known as turtles, another name for that you'll see is testudines. Testudines. Colonia, the turtles. Were long classified as anapsids because living forms of turtles do not have any openings behind the orbit on the side of the skull. Okay? But fossil record evidences are pointing to a possibility that there were turtle-like organisms that had openings on the side of the skull in that diapsid arrangement, and that possibly the turtles just lost that as a secondary kind of development along the way. So they're not classified as anapsids, even though they are structurally anapsid. They don't have holes in the side of their head. They're grouped with the diapsids. So we have turtles. The next lineage up here, I'm going to write this in brown here. These are the archosaurs. Let me see. That means, well, anyway. Includes the crocodilians, that's your alligators, crocodiles, caimans, and such. Crocodilians, that's one lineage. The dinosaurs and aves, the birds, that's another group there. The birds. Dinosaurs, birds, and crocodilians are archosaurs. These had their teeth set into sockets. Kind of a unique trait at this point to have teeth set into sockets. So sometimes we call this the Archosauria lineage out this direction. And this other direction over here, these are lepidosaurs. Lepidosauria. Lepidosauria has two primary branches that are living today. First of all, the rhynchocephalia, that means beak-headed. Its head is like a beak, kind of like bird beak kind of arrangement, just in shape, not in terms of its overall structure, just in its shape. The Tuatara, also known as Sphenodon, in the genus Sphenodon. This is a reptile found off of the New Zealand coast on some islands there, where it's known from. Looks kind of like a iguana, like a lizard. It's kind of a stout body, not as long a tail as in the iguanas, but anyway. A truly primitive kind of skeletal structure, very different from snakes and lizards that we have today. So the other group, the squamata, squamate reptiles, that means they lay flat on their belly, the snakes and the lizards. So lepidosaurs represented by rhynchocephalia and squamata. Archosaurs represented by crocodilians, dinosaurs, and birds, the aves. That term dinosaurs is kind of misused sometimes, referring to things that are maybe along the synapsid lineage or anapsid, or another group that's extinct I don't have on here called euryapsids. But anyway, so we have those reptiles all up this way. Now, there's another group of reptiles called synapsid reptiles, where supposedly the syn word together implies that the two lateral openings of the diapsids came together to make one opening on the side of the skull, which is questionable. But anyway, there's only one opening on the side of the skull behind the orbit in these. And we have three branches of living forms that are all mammals. So they were thought to be reptilian forms at the base of this synapsid lineage, and then mammalian forms out here. So this is all mammalia out this way. And we have three major groups of mammals we need to bring in here. Prototherians, also called monotremes. This is the platypus and the echidna, ECH. IDNA. Echidna, or spiny anteater, it's sometimes called. So those are prototherians. These are the egg-laying mammals. The egg-laying mammals, completely unique kind of group. There are like two species of echidna and a single species of the what we sometimes call the duck-billed platypus. So the platypus and the echidna are examples of monotremes or prototherians. Next, metatherians. Are your marsupial mammals. Those are your kangaroo, koala, opossum, Tasmanian devil, wombats, all those things. Mostly Australian, some in South America, the marsupials or metatherians. And then finally the eutherians. These are placental mammals. Placental mammals. So these three groups differ primarily in the way that they give birth. These are egg layers. They produce an egg, lay an egg. These are the prototherians. The next group up, metatherians. They give birth to a very, very tiny kind of embryo that has to move through across the mother's body to the pouch, to get into the pouch and attach to a nipple to start feeding and to develop in the mother's pouch. And then placental mammals retain the embryos inside the body with a complex placenta structure to deliver nutrients between the mother and the growing baby animal and the placental mammals. Don't forget that your primary mammalian characteristics from our other chart were hair, memory, tissue, and three middle ear bones. So that's an overview of the tetrapod lineage, all the major groups that are alive today, a lot of extinct groups not represented here in the chart.